Okay, this week's topic is on two-way tables. This is a type of statistical data organization as well as analysis. So, starting in with what the definition of a two-way table is. So, a two-way table displays two categories of data collected from the same source. You can use the two-way table to draw conclusions about how the categories are related. So this is an example of a two-way table here. In this case, the two categories that were taken were the students, whether they studied or did not study, and then whether they passed or failed the class that they were taking. And so those are the two categories, and then the numbers that fill into the table are basically the results of the study. A lot of times two-way tables can be used to things like surveys or questionnaires to be able to kind of analyze the results of those. Okay, so to talk more about the two-way table and kind of explain what it is, here is how a two-way table works. So each side, in this case there's kind of two sides to the two-way table. There's a top and then there's the left-hand side column. Those represent the categories of the data or a question from the survey. So each column and each row are the possible outcomes or options in the data. So going back to the table that we had here, again, whether the students studied or did not study were the possible outcomes for that part of the question, and then whether they passed or failed the class is those possible outcomes there. So two for each here, and that's why it creates, as you can see in the yellow part of things here, two columns and two rows for the data. But then the final column and final row is always for the total of that column or row. So you'll see out here to the far right then it's got a total column, and then all the way at the bottom of the table is a total row. And so those should always be what you see on the far right and the far bottom part of the two-way table reserved for the totals. And just like with the word total in math, it's talking about the sum. And so the numbers in each row or column must add to make the total at the end of the column or row. So if we go up here and look, we have 21 students that studied and passed, and then one student that studied and failed, and therefore 22 is the total number of students that studied. Did not study, we had 2 and 6 for a total of 8. And then for the going across with the passed row, so we had 23 total students that passed this class or this test or whatever the data is showing here, and 21 of those studied, 2 of those did not, and so 23 total that passed, and then 1 that studied and failed, 6 that did not study and failed, and so for a total of 7. And then always in the bottom right down here, what I like to refer to this box as it says down here in the notes, is the box that represents the total. It's just what I like to refer to it as because it's the box at the end of the total column and at the box at the end of the total row, so it's the total number. But this should always represent the total number of individuals that were surveyed or number of samples that were collected from the data. So as it says here, 30 students were surveyed, and this number represents that. And notice that both the column, 23 plus 7, is going to make 30, and the row, 22 plus 8, is going to make 30. So those two numbers should always add up there as well. If numbers are missing from the table, though, and we need to fill those in, we can use either addition or, depending on what it is that we're missing from the table, if it's one of the data numbers, then we might need to use subtraction to backtrack and be able to figure out what those missing values are. Okay, so a lot of times that's where we start with a two-way table, is we have some numbers either in the totals or in the data itself that we were not given, and we need to be able to use the idea of a two-way table to figure out what those missing numbers are. Okay, so that's what we're being asked to do here in the first example. So the examples, find the missing values in the following two-way tables. So this was participation in a triathlon, whether they participated or not, so either yes to yes or a no to that. And then the gender of the individual, either female or male. And so we have some of the numbers that we have filled in here, but we're missing some. And so knowing how a two-way table works, this number for the 24 is the number of females that have participated in a triathlon, would have to add with the numbers of females that did not to create the overall total. And so if I know that this has to add with that to make that, well, that means if I take my total, subtract away the number of yeses, it should tell me the number of no's. So I'm going to take 137, and subtract away 24, and that'll leave me with 113 for this box here. I can do the same with the total column. I know 306 total people were surveyed here. 137 of those were female. So if I subtract 306 minus 137, it'll tell me that 169 total males were surveyed. I can then do the same thing now that I know that there were the 169 total male individuals surveyed. 142 of those did not participate, so if I subtract from 169, 142, it's going to tell me that 27 male individuals did participate. And then for my final boxes down here, the total of yeses and the totals of no's, I now add these numbers, right? Because these are the data numbers. If I have to add those, they need to make the total numbers down here. So now add 24 plus 27, and we get 51 total individuals that did participate in a triathlon. And 113 plus 142 makes 255 that did not. And now just to verify, I'm going to go ahead and add 51 and 255. But I also get 306 then when I do that. And so that's going to verify that these numbers and the way that I made the table should be accurate because the total now that I ended up with for these two numbers also makes my total number of 306 down here. Okay, practice that one more time down here. This time we have dual enrollment students. So they are enrolled in multiple classes or in multiple sites. I guess could be what dual enrollment shows here. So yes and no are the options there, and then class that they're in, either sophomores or seniors being surveyed here. Okay, so let's see, numbers I can figure out. So here I have an empty box that I know 432 is the total number of no's, and 247 of those were sophomores. But if I subtract those, 432 minus 247, I can get this number here. Now that can lead me to being able to add these two numbers together to make my total number of seniors. So 83 plus 185 gives me 268. Let's see, then I can either subtract the 550 from 432 from the 550 to get this one. I could also do subtraction to get this total number here. So let me do each of those. So 550 minus 432 gives me 118 total yeses. 550 minus 268 gives me 282 total sophomores. And now either subtract the 118 minus 83 for the number of seniors to give me the total number of yeses from sophomores, or the 282 minus 247 should also give me that number. So maybe verify both just to make sure that they're both giving you the same number. Helps you see that you accurately filled out the table, or I could go back now and add the 35 that I just got for the number of sophomores that said yes to 247 and verify that it indeed gives me 282. Okay, so that's a two-way table, and that's how, if we're missing data from the two-way table, how we can fill that information in based on the fact that we know that each column and row has to add to make the totals. So, a relative frequency. It's the ratio of categorical data number to a total that represents the frequency that of the event occurring. Okay, so the idea here is a relative frequency is kind of telling us how frequently that event is occurring from our survey or from our data. And again, it's a ratio, so remember ratios are fractions, and so it's a data number divided by a total number. And for the idea of a relative frequency, we're going to write it as a decimal when we get our number, rounded to the nearest hundredth unless otherwise specified. Or if we're asked to, or if we're given the data as percents, then maybe we'll use percentages. But either one would work. But when you take the data number and make a ratio out of it over the total, if we want to turn that into a decimal, then to determine the relative frequency, we're going to divide. So we're just going to actually make that division of data number divided by total number. And by doing that, we can then construct what's called a relative frequency table. And it's going to use the same columns and rows as the original two-way table that we had. So here's an example where we're going to create a relative frequency table for the following two-way table. And so here we have the gender, male or female, of individuals that were surveyed, and what party type that they would like to have, whether it be bowling, skating, or dancing. So maybe this was like a school survey that was done to find out what kind of class party or end of the school year event kind of thing to be able to have, maybe like a reward type situation. But the idea is, so here's our data, and then notice that this table down here it matches exactly. So it's got the same columns and rows all the way through. So what I'm going to do is I'm going to take a data number. So let's start up here in the top left with, there were 6 male individuals that wanted to choose bowling as their event. And we're going to divide that by the total number of students that were surveyed down here, which was 26. So I'm going to make a ratio of 6 out of 26, but then I'm just going to go ahead and divide that. So 6 divided by 26, and it gives me a decimal, which is 0.2307, and it continues on here. Now, I'm going to round to the nearest hundredth. So the 3's in the hundredths place, the 0 would tell it to stay the same. So we're just going to round this to 0.23. For the sake of the box down here, I'm just going to abbreviate it as 0.23, just drop the 0. Okay, and then move on to the next one. So the next one, I'll go maybe to my right here to the number of females that chose bowling. So that would be 2. Divide that by the overall total number of individuals that were surveyed out of 26. And so my relative frequency here, 0.076. So the 7 is in the hundredths place. The 6 tells it to round up. So I'm going to make that 0.08 or just 0.08. And now what I should find is that I could either add those two numbers together to make this total number over here, or now take my 8 and divide it by the total number of individuals that were surveyed. This is the total number of individuals that chose bowling, which was 8, divided by 26, and I get 0.307. So the 7 is going to tell the 0 to round up to a 1. But what we should find is that that's the same thing as adding 0.23 plus 0.08, and indeed it is to make 0.31. Sometimes, because we're rounding here, that number can be a little bit off or a little bit different than what you would get by adding these two. But either method is really fine to use there. They're going to be within 0.01 or 1/100th of each other there. Okay, continuing that method through the table. So now take 3 for the number of males that chose skating, divide by 26. This would round to 0.12. 11 divided by 26. 0.42. 14 divided by 26. 0.54 actually when it rounds. So here's an example where adding these two, actually no, in this case would give me 0.54, so that is accurate. Okay, and then 1 divided by 26 gives me 0.04. 0.3 divided by 26, 0.12. Okay. And okay, so here's an example where it's a little bit off, right? So I have 0.04 and 0.12. If I were to actually add those, I'd get 0.16. But we see here when you actually divided 4 divided by 26, the rounded to 0.15. So it's okay that these numbers aren't exact. Again, it's within a hundredth of what you would get if you added them. Okay, now the same thing should be shown here. If I add this entire column up, it should give me the total number down here, which if I also take 10 divided by 26, I get 0.38, which, let's see, 4, 5, 6, 7, 8, 9. So it'd actually be 0.39 if I were to add it. So a little bit different there, but again, within a hundredth. And finally here, 6, 2. Okay. And then down here for the final one, you're going to be taking 26, total number, dividing it by total number, which is also 26, which gives you 1. Or 1.00 if you were to be going to the hundredths place still. And that should always be the case, right? So down here in the bottom right, if you're doing a relative frequency table, which means you're taking the number of the data numbers and dividing them by the total number, this number should always work out to be 1 down here. And if we look at adding our total numbers down here, our frequencies, 0.38 plus 0.62, well, that makes 1. And 0.31 plus 0.54 plus 0.15, that also makes 1. So those also follow the same pattern of having to add the total columns to make the total as well. Okay. So that's taking a two-way table, turning it into what's called a relative frequency table. Now, how we interpret a relative frequency table, or what these numbers mean, is that if you were to want to be applying this to another number of individuals, so let's say this was 26 individuals that were surveyed, but you wanted to know for the entire school, which had 350 students in it. Well, we could assume then that 0.38% or 0.38 of the population of the male students wanted to choose, I'm sorry, that's just what was surveyed here. Let's go to these columns over here, or these rows. So of the bowling, 0.31 wanted to choose bowling. So if I had, instead, 350 students, multiplied that by 0.31, I would assume that around 108, 109 students of those that were surveyed would want to choose bowling. I, again, can turn these into percentages, so they act as percentages, right? So like 54% of the students chose skating, or would like to do skating. Okay, because remember, to turn it into a percentage, I moved it over 2 decimal places to the right to make a percentage out of that. Okay, so that's really kind of what these are showing here. Our relative frequencies are kind of like the, it's again a ratio, but it's also like the percent of students or people that chose that categorical data. Okay, and then one last one, conditional relative frequency. So conditional relative frequency, the word conditional means like it depends on something, right? Or there's some kind of conditional reason for that data. So it's still a ratio of categorical data to a respective, this time, total number in a column or row. So it's basically going to narrow the option down to a certain total number to be using instead of the overall total here. So instead of dividing by the total, we choose whichever respective or prospective total number that we need to use. So to find this, we're still going to divide, it's still going to be our method, the categorical data number by the respective total number that is in question. Round the answers to the nearest hundredth, or convert it to a percent if necessary. So here we have the following two-way table shows the results of a survey given to different types of engineers, and whether they preferred the subject of science or math. Use it to answer the questions that follow. So we have electrical, chemical, or mechanical engineers, and then whether they chose science or math as their preferred subject. So what is the relative frequency of chemical engineers that preferred math? So here we want to look at just the numbers of chemical engineers and those that preferred math. Well, here's chemical engineers and those that preferred math, so that would be the number 80. that we're going to divide by the total number of chemical engineers, because it's just asking about chemical engineers in this case, not all of the engineers in total. So there was 171 total chemical engineers. We can see that by the total column at the end. And so if I take and divide here 80 by 171, I'm going to get 0.467. So the 7 tells the 6 to round up to a 7. So I get 0.47. And this is my answer, because that's a relative frequency. It's a decimal number given to the hundredths place. And so that basically shows me, if I were to think about it, what the meaning is here, is that 47%, right, is what that would convert to as a percentage, of the chemical engineers preferred math. Okay, for number 2, of the engineers that preferred science. So all of my total science then is what's being pulled into question here. So that number is 262. What is the relative frequency of those that were mechanical engineers? So of the total 262 science preferring engineers, 81 of those were mechanical. And so to figure out what that relative frequency is, take 81, divide by 262, and after rounding, you're going to get 0.31. Okay, and again, the meaning of that is 31%. So of the engineers that preferred science, the relative frequency, 31% of those were mechanical engineers. Okay, number 3 is asking for the percentage. So now that it's asking for the percentage instead of the relative frequency, I'm going to actually convert my relative frequency number to a percentage for my final answer here. So what percentage of electrical engineers preferred science? So now I go up to the table. Electrical engineers, there was 175 total. And of those, which ones preferred science? Well, there was 90 of them. So 90 out of the 175 total. And after rounding, that's going to give me 0.51, which, if I need to convert that to a percentage, again, I need to move that decimal place over 2 places to the right. And that gives me now a relative frequency, or in this case a conditional relative frequency, because it's out of a specific total number, of 51%. So 51% of the electrical engineers preferred science. That's how I interpret that. Okay, so that should give you enough information to be able to go attempt the worksheets now. It's kind of an abbreviated set of notes, no conclusions or summary on this one. So go find that worksheet on two-way tables, and more to come throughout the rest of the week here on this topic. Again, we'll be doing a check-in on Wednesday if you need help with any of the material here with this, and make sure that you're answering the daily questions. Okay, good luck.